Hey everybody, this is going to be our lesson that we would have normally done in whole group on Monday, March 28th. But I unfortunately had to cancel class because I was stranded on the side of the road and I wasn't able to have class. So I hope you guys have time to watch this video and we'll get something out of the lesson. But of course, if you have any questions, please do not hesitate to reach out to me or attend office hours or sign up for one-on-one. Okay, so this week we have surface area of cones, volume and surface area of spheres, and then also taking everything that we've done for surface area and volume of 3D solids and putting it together to make composite figures. Notice your assignments this week. We have our a quiz on Tuesday over 4.09 right here, and then we have our USA test prep on Thursday. Okay, let's go ahead and get started. So I want to review the parts of a cone, and really the big ones that we need to look at are they're all pieces that we've talked about before. The base, right? The base of a cone is always going to be a circle, okay? The other big part is the radius, okay? That's just going to be from the center point to the outside of your base. And the other point, or the other thing that we're talking about is the different types of height. So this first one stands straight up, okay? Its height is going to go straight down the middle, okay? Now, if we look at this second or the middle cone, okay, the radius, we don't even need to review that, but I do want to show the difference between the height, which goes from the vertex to the center of the circle at the bottom, and the slant height, okay? The slant height, just like we had with the perimeter, not the perimeter, the pyramid, just like we have with the pyramid, the slant height is on the outside of your cone, okay? And the last one is the oblique cone, And this one's kind of funky because it's leaning. The height has to be perpendicular to the base, so it's actually the height is outside of your cone. Okay. Let's put this to use. So the first thing we're going to talk about is the volume of the cone. The volume of the cone. So the formula goes 1/3 times pi times radius squared times height. Okay. So of course we have our height here in our picture and then the radius. Okay. So when we're doing the volume, that's on the inside of the cone, right? So that deals with the regular height of your cone and not the slant height. Let's look at an example. Okay, so let's identify where the radius is. So the radius is going to be this guy right here. So our radius is going to have a length of 12. And then the height. Okay, where's that height at? The height goes down the middle. So our height is going to be 8. So now we're just plugging those into our problem. Or into our formula. So it goes 1/3 times pi times radius squared times our height. So let's plug in our pieces. We got 1/3 times pi times radius, which our radius is 12. So it's going to be 12 squared times the height, which is 8. Okay, I'm pulling up the Desmos calculator for us. Remember, whenever you go to desmos.com and you go to the calculator, you got to bring your keyboard up. So the first thing is the 1/3. That can be tricky, but we're just going to put 1 divided by 3, okay? And we're going to put that in its own set of parentheses. Then we have the pi button. And then we have our radius squared, which was 12. And we're going to put this button right here where it says a squared. Squared, and then times our height, which was 8. And there we go, 1,206.37. So let's see here, 1,206.37, and this is centimeters, and this is volume, so it's going to be centimeters cubed. Now, don't forget that you want to look at your answers to see if they are leaving it with pi in there or if they're multiplying all the way through. Okay, we're going to do some examples of that where we leave pi in there, but just be careful because if they're asking for, or if it has answer choices, look to see if the answer choices have pi in there. If it doesn't have answer choices, then look for it to say leave in terms of pi, which that means leave pi in your answer, okay? Okay, so surface area. Surface area is a little bit more in depth, only because it has a little bit more to the formula, and we're not totally used to using that slant height, okay? Remember, the slant height is on the outside of your cone, okay? And the radius is still from the center to the outside, okay? The formula goes pi times the radius times the slant height plus pi times radius squared, okay? So let's go ahead and, and take note right here. It says down here at the bottom, pi RL. So this part right here, let me go ahead and highlight this for you, okay? Pi RL, that is if they ask you to find the lateral surface area, okay? The lateral right there. And then the back half of it, the pi r squared, that's just the area of the base. Because remember, the lateral is on the outside, but it doesn't include the base, okay? So let's do an example. And this one, it doesn't specifically say if we're going to find lateral or total, so we just assume we're doing total. So let's highlight the pieces that we need. The first one is the slant height, okay? So slant height goes on the outside. And then we need the radius, which is from the center to the outside. Notice here, for this formula, we need slant height and radius. That's it. But they've given us 3 numbers. They're trying to throw us off. We don't need the 8. We do not need him. He is extra information. So let's go ahead and plug in now. The slant height was that 14.4, and the radius was 12. Okay, so the formula goes pi times radius, which was, let me go ahead and fill this in here, pi times radius times L plus pi times radius squared. Okay, so we've got pi times our radius, which was 12, times our slant height, which is that 14.4, plus pi times radius squared, so 12 squared. Okay, I'm going to solve this first with just, and that's not volume. That should say surface area here. I'm going to solve this first with just leaving it in terms of pi. So what I'm going to do is I'm going to cover up, or I'm going to ignore the pi. I'm going to ignore the pi symbol really quick, okay? I've clicked on something here. Hold on. Okay. I'm going to cover up the pi because I'm going to ignore him. Okay. So I'm going to ignore the pi there, and I'm going to ignore this pi here. So all I'm going to do is 12 times 14.4. 12 times 14.4. And that gets me 172.8. Okay. Here we go, 172.8. But I had a pi there, right? I had a pi, so I'm going to erase this pi. I'm going to erase that box. I'm going to bring my pi back, okay? Plus, and then I have 12 squared, which I know that one is 144, and I'm going to bring that pi back. Okay, so again, I'm leaving in terms of pi, okay? So it's kind of like if I said I had 172.8 cookies plus 144 cookies. All I'm doing is adding those together. So I'm going to do 172.8 plus 144. So I get 316.8. So my answer is 316.8 pi. And again, this is leaving in terms of pi, and that's centimeters squared. Okay. And if they want you to solve this problem all the way through, remember, we're just taking pi. We're plugging 3.14 in there for pi, or you're using the pi button. Okay, let's look at another example here. So it says find the surface area of the cone in terms of pi. So look at our answer choices. They have a pi in there, okay? So we're going to leave pi in our problem. So let's just highlight the pieces that we need, okay? The radius they're telling us is 2. Awesome. Okay, and then the slant height is this 7. So let's plug in here. So our surface area is going to be equal to pi times the radius, which we said was 2, times the slant height, which is 7. And then we have pi times radius squared, so 2 squared. I don't even think we're going to need decimals here. Remember, we're forgetting the pi for right now, and we're just multiplying or putting the whole numbers together. So 2 times 7 is going to give us 14, and we have that pi there. Then we have 2 squared, which is 4 with the pi. So we have 14 pi plus 4 pi. So we have 18 pi. So our correct answer is B. Okay, we're going to jump over to spheres. So spheres are balls. We know that. I mean, I think even my kindergartner is learning that we don't call the 3D solid that looks like a ball. We don't call it a ball. We call it a sphere, right? You've learned that for a long time. Spheres, even though they're 3D, they still have a radius and they still have a diameter, okay? And the radius is still half of the diameter, okay? Of course, there's some examples of a sphere. But let's take a look at surface area of sphere. A surface area of the sphere, there's only one type, and that's the total. There is no lateral because a sphere doesn't have a base, okay? So it's just all or nothing. And the formula goes 4 times pi times radius squared. Easy enough. We just need to know what our radius is. So let's look over there at the example, and the radius is 16. Okay, perfect. So we've got we got 4 times pi times 16 squared, okay? So let's put that straight into Desmos, okay? So we have 4 times pi times 16 squared, and we get 3,216.99. What was that again? 3216.99. Okay, 3,216.99. This is surface area, so it's going to be centimeters squared. And remember, surface area is on the outside of your sphere, okay? The outside of your sphere. So it'd be like peeling an orange, okay? Peeling an orange. The rind or the outside of your sphere, your orange, that's the surface area. Okay, the next one is volume. This one's a little bit tricky only because it has a few elements that we're not used to seeing. Most of our formulas have had r squared, but this one, because it's volume, it is r cubed. You see that? Also, the fraction is a weird improper fraction of 4/3, okay? So again, weird fraction, and the radius is cubed. So pick up on that, focus in on that it's a little bit different, okay? So let's see here. The first, we just need to know the radius from our problem. And I talk about this a lot in class. How could they possibly trick us on these? Well, they could give you your diameter instead of your radius. And remember, to find the radius, we just divide the diameter by 2, okay? So for this problem here, the radius is 6. So it'll be 4/3 times pi times 6 cubed, okay? Let's go straight to Desmos. Now, when we put this into Desmos, okay, you've got to put that 4/3 into parentheses. So parentheses, 4 divided by 3, okay, close parentheses, then pi times radius cubed. So let's see here. The radius is 6, okay? Radius is 6. So we're going to have 6 to the 3rd power. There is no special button for 3rd power. You have to use this one. That way we can put in our exponent, whatever exponent we want, which is a 3. So we're going to do that, 3. Okay. And there it is, 904.778. Now this 8 here is going to round the 7 up. So it's going to be 904.78. 904.78, and this would be centimeters cubed for volume. Okay, we have another problem here. So it says the diameter of a sphere is 2 feet. Okay, so here's my sphere. I'm sorry, that is a horrible drawing. Okay, all the way across. All the way across is going to be, the diameter is 2, right? The diameter is 2. So that means that the radius is just 1. Our radius is 1. Okay, so let's plug in here. I'm going to say this. Our radius is equal to 1. So the volume, the formula goes 4 over 3 times pi times 1 cubed. Now, looking at my answers, okay, there is no pi in there. It also says round to the nearest tenth. Well, this will be easy because we have the multiple choice questions here. However, when you have a quiz, sometimes you have to put the answers in yourself, right? It's open-ended questions. You got to pay close attention to what they want you to round to. When you round to the 10th, that is 1 decimal place, okay? Let's go ahead and plug this into Desmos. So we have, okay, we've got 4 divided by 3.
Sorry, I didn't get that.
Sorry, Siri didn't get that. 4 over 3 times pi times 1 to the 3rd. And we got 4.188. Now, 4.18. And they want 1 decimal place. They want it to the 10th. So this 8 is going to impact the 1, right? So it's going to round to 4.2. So the correct answer is A. Okay, so with these spheres, you got to ask yourself, do they want the surface area, which is on the outside? Do they want the volume, which is on the inside? And then you've got to say, okay, are they giving me the radius or are they giving me the diameter? Okay, pretty easy on these because you only need one. You're only trying to find, or you need one thing to plug in, and that's the radius. Okay, we're going to put it together. We're not going to solve these problems completely. We're just going to talk about them for a second. So composite figures is when we put it all together, okay? So how would we find the volume of this shape? This shape is like a roll of toilet paper, okay? It's not solid, right? It has an empty tube down the inside. So in order to find the toilet paper part, or like the part that's left, okay? The cylinder donut, basically, okay? We would find the volume of the big cylinder minus the volume of the inside cylinder. Now, of course, we can't solve this problem because we don't have any measurements on here, okay? But just try to visualize that of how you would find the volume of what's left. It's like you're taking the inside, you're taking it out, okay? What about here? This is a true example of a composite figure where it's 2 or more shapes that are put together. So we practiced this a lot when we had our 2D solids and our 2D shapes. That was like when we had things like this and we found the area of them. We can do the same thing for the volume or also the surface area. But this, there's 2 shapes here. We have the cone and we have the cylinder. So we would find the volume of cone, which is that top part, okay, plus the volume of cylinder. And we just get the total. That is all we would do. Okay, guys, here's a great wrap-up slide of all the different formulas for volume and surface area of these solids for prism, cylinder, pyramid, cone, sphere, all of them, all in one sheet. But also don't forget that we have the formula chart as well. I've given that out several times in class, but also you can find it on the geometry resource page. Remember, that's located in the class, and it's also located at that link, or you can get to it by the QR code. Okay, so for this week, our 2 assignments they're the 4.09 quiz and the USA test prep assignment on Thursday. But don't forget, you should be going through all these lessons, doing the examples, and looking at any resources that I have on the resource page. Okay, you guys have a great rest of your week, and I will talk to you soon. Bye-bye.